Okay, good morning, everybody. I think most people are here now. Perhaps somebody could just say whether the sound and the vision is okay.
Yeah, everything looks fine to me.
All at the same time. Good. The true and correct presentation is here. So for those of you who are still with us yesterday evening, you will remember I said I was going to put this section on debugging and profiling till first thing this morning, so that's what we'll do. And then there are these couple of small sections which won't take very long to deal with. So I expect this section on debugging and profiling to take perhaps 40 minutes to an hour. We'll have a break at 10 o'clock. We'll come back at 10:30 and just finish off any remaining issues. And then basically the idea for this morning is for you to be able to have a go at whatever you wish to do, and we'll be around to try to help if necessary. And the scheduled finish is at 1300 hours, 1 o'clock this afternoon. Are there any outstanding questions from yesterday? Before we go on, okay, you can always just plonk them into the chat, and either Julian is here and Queven is here again, and they will dive in to try to yes, Queven as well. Yes, there will be a chance to have another look at this issue of this module load EPCC job env, which caused at least one accident yesterday. So I'll try to remember to say that at the time. Okay, so if there are no questions, we'll start this morning with the issue of debugging. So this is something that you may never actually need to do, or may need to do only very rarely. But if you do, it can be extremely useful. So as I think I mentioned yesterday, my go-to tool of choice in the Archer context for debugging would be DDT, which is really very useful. That's not available, or will not be available on ARCHER2, at least in the immediate future. So we're going to have a look at some of the debugging tools that are available. The first of which is GDB for HPC. So anybody use GDB before? Anybody? Okay, maybe not. GDB is fairly standard debugger. GDB for HPC is a special version of this, which really lets you manage the complexity associated with the fact that it will be a parallel executable that's running. So that is available via the module system, as we saw yesterday. Another useful tool is Valgrind. Anybody use Valgrind? Okay, maybe not. So this is again a tool particularly useful if you have memory leaks, or if you are allocating memory and losing it and forgetting to free it again, this is a tool of choice for finding those kind of things. And again, there's the Valgrind for HPC is basically a special version which is going to manage the fact that you have outputs coming from potentially many parallel tasks. There's also a thing called ATP, which is a Cray, well, no, it's not, Cray provide ATP can be useful in some context. And there's also something called Cray comparative debugger. Not sure if that's available yet. Julian may be able to comment.
Not that CCDB is available, but runs incredibly slowly because of the X interface, and ATP is not currently available as far as I'm aware.
Yeah, is that true? I thought ATP had arrived. Okay, so yes, so there's a general issue there. If you're running at home, in particular, if you need anything which needs a graphical user interface, you may be doing more or less well. So we're trying to avoid anything, I think, which looks like a graphical interface at the moment. So Cray provide various documentation on these things, but we're going to have a look at GDB for HTB. Start that again. GDB for HPC. So to debug an application, we actually need an application. So without further ado, we should log in to the machine. Okay, I'm going to move into the work file system. And I'm going to download with this wget. I'm just going to cut and paste this command here. You should be able to do the same. So here, what we've provided here is this GDB for HPC exercise .c, which is a C program involving a message passing interface. By show of hands, who knows anything about the message passing interface? Where's my maybe a couple of people. Okay, I'll just have a quick, maybe just have a quick look. Yeah, maybe just have a look at this. For those of you who don't, so you may wish to take a look at this. If you're an experienced programmer, you may spot the errors straight away. So this is an MPI program. So we're going to run this either on 1 or 2 MPI ranks. This just initializes MPI. MPI com rank allows us to identify which rank we are, and there are some commands here which are asking which rank we're on, and then there are some API calls, MPI send and MPI receive, which are going to pass some simple messages between rank 1 and rank 0 in this case, and then there's a function call down here which is going to perform some calculation. Okay, so we can compile this. The important thing for debugging is to use the -G option, which includes the symbolic information in the executable. By symbolic information, we mean things like the function names and the line numbers and so on. So the executable describes all the information we need, and we can call the output whatever you wish, really. Here it's called GDB exercise. So that compiles the executable. So we should have this executable there. So in normal circumstances, if we tried to run that, that will do something bad we're expecting, so we want to debug it. Okay, so there's a few incantations here we need to start up GDB for HPC. You can either cut and paste these into the terminal. These are just going to basically allow the command line to interact with Slurm. And you should type them. If you do type them, don't type them like I do. And module load GDB for HPC, and to start GDB HPC, we should see something like this. So we're now on version 4.8. If you have used GDB before, you'll be familiar with the fact that you get this prompt. So in order to do something, we need to actually start the executable. So there's a rather ugly launch command here, which again you can either cut and paste or type in. So bearing in mind yesterday's lessons on what is a well-formed set of Slurm options, we remember we must specify a partition. We must specify a QoS, a quality of service.
Kevin, you forgot a D in standard for partition.
Ah, well spotted. I'm going to ask in the first instance tasks per node. You'll notice there's this is tasks per node. That's not a typo. Yesterday I think we were using n tasks per node, and that's there are two different forms of that which are completely equivalent. I'm going to skip the CPUs per task because I don't think we need it just at the moment. I'm going to ask for an exclusive. So this one we haven't seen before. So this export -- export equals all is telling Slurm we want to export all the environment variables in the current shell, the current environment, to the batch system. So that hopefully will allow that to get off the ground. Also here I have to specify a label to which this executable is going to be referred to by, and I'm going to choose my program. This number in braces is the number of MPI tasks here we're going to be running. So I'm going to start with 1, which agrees with my -- tasks per node equals 1, and then the actual executable name, which I think I got right, GDB exercise. Yeah, okay. So okay, what happened there? Did I type one of those environment variables incorrectly? Yeah, okay.
I'm not sure you need to define those anymore.
Okay, so I reckon my mistake is there. Cutting and pasting is probably the safer option here. Yeah, okay. So this is slightly annoying. So there is, because I've used this label once, I'm going to have to use something else, I think, now. Okay, that's better. So if you make, so there's a lesson there that if you make a mistake in that launcher args section, there you get a rather ugly and uninformative error message. So be careful with that. If you've been successful, you should see something like this starting application, and it should tell you in my program A here, which is my label, and rank 0, I have reached the initial breakpoint, which is at, if you look at this point, it's probably for you guys, if you open another window with the source code, can be handy reference to use. I'm just going to stick with this one window to prevent too much confusion. Okay, so we've got an executable that is started. it's for those of you not done any debugging before, it says it's reached this initial so-called breakpoint. So it's reached that point in the program, and it's waiting for us to tell it to do something. So if we keep following the instructions, we can have a look at the prompt. We can give it a certain number of types of instructions. You can use help to get some help on what's available. So perhaps the most simple one is list. So list will show you where you are in the execution of the current program. So here's my label, my program A, and this is rank 0, and rank 0 is at line 9, which is the initial breakpoint, which we saw it announced when we first started up. And line 9 is the first executable statement in the program. If you're looking at the source code, so the execution is currently sitting there waiting for us to do something. So the typical or one typical way to use debugging is just to step through one line of execution at a time. To execute this MPI init at line 9, we type next. There's a small delay you may have detected there, and the message here is now telling us that rank 0 has now reached. If you can let's just make this window a little wider. We've now reached line 13, which is here. And you can keep doing that, and it will step forward. So if you reach whoops, let's not do that. If you reach a subroutine call, you can actually step into the subroutine with this command step. So that will transfer control, and likewise you can step out of the subroutine with the up, and that will return control to the next level up in the stack. So I've just managed to get some garbage in my terminal there. So the other thing that is useful, so we've got some variables here. So there's a variable rank, and there's a variable count. You noticed when I did one next there, we stepped forward to 13. Didn't go to 12 because that is just in rank. There is just a declaration. That's not an executable statement. So it's gone one step of next, has taken us from 9 to 13. If I do another next, it should take us to line 15, which is an executable statement. And that's that. So the other thing you can do, which is useful, is to examine the values of variables. So rank, which is initialized here at line 13 by this call to MPI com rank. So here we have rank is 0, as this we're just running on one MPI task here. If I do next again, we should reach the next executable statement at line 17, and I can have a look at count, for example, which tells us that the value of count is rank +1, which is 1. Okay, so that's the basic sort of idea of debugging. If you want, there are other commands which can be useful, things like watch informs the debugger. We want to be notified whenever a certain variable changes its value, and so on. Okay, so I think I've covered more or less everything there. Yeah, so there's an alternative form of this next, which allows you to step forward more steps at once. So there's a wee exercise here which is asking you to find out what happens if you keep stepping forward through the program. I'll give you a minute or two just to try that out. Yep, okay. Okay, so there is indeed, if we keep stepping through, I'm just going to go for broke, step through an extra couple of times, and you'll reach a certain point. Let's have a look. So I've got to line 18 here. When I hit next at line 18, I get this ugly looking error, which is, if we read through carefully, we can see this bit is saying invalid rank has value 1 but must be non-negative and less than 1. So we've clearly got a problem here in our program at or around line 18. So at this point we have to have a go at debugging it. So I'm going to get out of the debugger. And we're going to have a look at this, what's it called, GDB exercise. Okay, so the debugger was telling us the problem was at line 18, which is here, MPI send. Now, for those of you who speak MPI, you may be able to see what's wrong. For those who don't, I'm going to help you out here. In that example, in the debugger, I was running with one MPI task, and this API call here is requesting that we send a message here. This argument here is the destination, which is rank 1, but if I'm not running on 2 MPI tasks, I've got a problem because rank 1 doesn't exist. So we better run that on 2 MPI tasks to stand any chance of being successful. So that means going again. This time I think I'm going to cut and paste to prevent any accidents. Famous last words. So here's my and I need to run. So I need to run on 2 MPI tasks. So I need to change that number in the braces to 2, and I'm also going to just tell me I didn't do that. Change that to 2. And I'm going to change that to 2 as well. So I think, and I don't want that account equals my true budget code is TA009. Oh, that's rather weird, isn't it? That's all. Okay, I hope I've got that right. Oh dear.
Someone in chat points out that it should be GDB for HPC exercise rather than GDB.
My executable. No, you can't do something. Let's check this again. My executable is still here. It should be called. Okay. I've been done by my typing yet again. Let's try that again. Oh dear, not doing very well this morning, are we? Let's try this, get this right. you're probably ahead of me by now. Don't have to watch me make a mockery of it. Yeah. Right. End task per node equals 2, and whatever my executable was called. Okay, so I've still got, dear, oh dear. What's wrong with this? Because somebody should be shouting at me by now. Yep, I need a different name. Oh, so that's a new one.
That looks like it worked.
Oh yes, it does, doesn't it? Let's have a look. How are we doing? Okay, so here we go. After a bit of faffing around, hopefully you've seen something like this now. This is telling us now we're running on 2 MPI ranks. We've got ranks 0 to 1 here are at 9. So we can start to think about stepping through again. We've reached line 13, and again we've reached line 15, and so on. So if we have a look at count, for example, now we have 2 MPI ranks, so this is telling us that the value of the count variable is 1 on rank 0, and the value is 2 on rank 1. So, okay, so the name of the game is to find the next error. So now, because you see there's this logic in the program at line 17, rank 0 and rank 1 have diverged. Rank 0 is at line 18 and rank 1 has gone to 21. So that's telling us if we try to step forward again, rank 1 has, rank 0 has got to 19. Let's try to keep going, and you may have reached the point here where it's just telling us if we keep trying to step forward, it's just telling us the application is running. So this suggests that something is happening, but we're actually not stepping forward through the program. So at this point, I think we need to have a look at the program again. So I'm going to shut this down. What's it called? So there's another MPI problem here, which, if you're not familiar with MPI, you'll need help to resolve. So you'll notice that both branches of this conditional statement have this barrier here. So MPI programmers will be on the lookout. I'm just actually going to move this down here. So this is effectively the same thing. So MPI programmers will be aware of the potential for deadlock in the program if this message is not completed correctly. And I think there's actually another MPI problem here which people may need help with this. Actually, I think there are two problems here, aren't there? I think there are two. So the send is going from 0 to 1. I think the receive should be the other way around. So that should receive from 0. This other argument here is a unique tag which needs to be the same in each case. So I'm going to choose a value for the tag which is the same in both cases, and I think that should get around the problem, I think. Okay, so I think you may want to have a bit of a go with that. So I think there's yet another problem in this program which you may wish in your own time to try to have a look at. But that's the basic sort of idea of the debugger. So you get the kind of thing that the debugger is good for is if you have, for example, a segv in your program crashes with an invalid memory reference, and you've got a big program, you don't know exactly where that's coming from. It's good to run that through the debugger, because if you just run it, it will probably just run until it crashes, and then you'll know the should allow you to identify the location of the crash or the line number that is causing the problem. Okay, so I think that's more or less the idea. I think that's. So if you, as I say, debugging may be something you don't do very often, but can be important if you do have a problem. Any questions on that? Yeah, okay, I think that's so. So this particular example where we have these deadlock is always a problem in that you may have a non-response, but if you're seeing that, you should be thinking, aha, I have I potentially have a deadlock. If it's more something like an error which causes a crash, the thing will crash and report the error and the location. Okay, so that's debugging. So how are we doing? I'll just perhaps go through the profiling as well before the break. So we've done our debugging. We hope we've got a working program. And the next question we might ask is, what does my performance look like? And the answer to the question is, we need to try to measure the performance, and this is where profiling tools come in. So the main profiling tools on Archer are the Cray performance measurement and analysis tools, generally referred to as CrayPat. So in the module system, you may remember yesterday we saw all these things under perf tools. This is basically the CrayPat stuff in various forms. So you'll notice there's a lot of different versions here, and basically which version you choose may depend on exactly how heavyweight a process you want to undertake. So the full perf tools module, or the full CrayPat, gives you the ability to do full instrumentation, and we'll have a bit of a closer look at that later. The sort of recommended starting point is to use this thing, CrayPat Lite, which is a slightly lighter weight version, which is slightly easier to use in the first instance. And there is an associated module on the system, which is Perf Tools Lite, which provides the relevant functionality. Cray also provide something called Reveal, which we're not going to have a look at today. That's aimed at analysis largely of loop level parallelism and associated OpenMP parallelism. And there are various other components which you can look at if you're interested. There's a page here. The Cray user guide has a fairly reasonable description of this stuff, actually. So the easiest thing to try and have a go. So we've again given you an example here, which can be fetched using wget from the machine. So I think I'm going to create a new directory for this. And we can get that package. So this is a tar file, so this needs to be unpacked. You can do this with something like extract that file. And you should find yourself with a directory in body par. So we'll have a look in there. So yes, here's an interesting thing. You'll notice this is one of these systems where the prompt wants to echo the current working directory, which I tend to find rather annoying. So I'm just going to get rid of that. So we can see what we're doing. So in that directory, you'll see we've got a make file, some code written in C, and there is a that run.slurm is a slurm script which should allow you to submit the program to the queue system. Okay, so here's the important step. We need to load the perf tools Lite module before we do anything. Perf tools Lite. Let's check that's loaded. Yep, we're down here. You'll also note there's also this perf tools base, which is in there by default, but we also need this perf tools Lite. So if we now compile the program by issuing the command make, this goes through a series of compilation steps. Here's the link step, and at the link stage you'll see we generate message saying created perf tools instrumented executable. Okay, so what this has done is automatically behind the scenes it's gone into the executable and inserted the necessary code to do some sampling of the performance. So we should be able to run that executable in the queue system via the script provided, which we'll just have a look at here. So you should just go ahead and do that with a couple of provisos. The first proviso is that today's account is TA009 for our course. And there's something else wrong with this script, or at least one other thing. Can anybody see what it is? By comparing with yesterday's examples. Something is missing. Something.
Leaf has answered in chat that it's missing the default environment.
Yeah, good. Right, yeah. So I think we need to do this. If you try to run that, you'll get a horrible message about missing dynamic libraries related to libfabric, and the reason for that is we have forgotten to put back what's it called, EPCC job env, which was going to load the default programming environment. There's also, as we spotted yesterday, this is also doing one or two other things, which includes actually setting OMP num threads equals 1. So this really wants to be the first executable action in your script, so that you don't accidentally undo anything that comes later, which we saw one example of yesterday. Okay, so given that, I think the script should work, and we can submit it in the usual way. Give it a couple of seconds. I think it only should take a couple of seconds. Okay, hopefully that's finished. So what's happened here? You'll notice a few things have appeared. So this was our executable, this nbody parallel.exe. Having run it, you'll see a couple of things have appeared. There's this strangely named directory, which is actually holding the results of the profiling, and our output is our standard output is down here in slurm-out.txt. So if we have a look at that, so this again, so here's our default environment coming back. You'll see we've got an extra line of output here, which is looks like it's coming from craypat. This stuff is output from the program itself, I believe. And at the end, so I think that's the last line of output from the program itself, and then we get a whole slew of statistics from craypat. So this is basic stuffs about the number of MPI ranks and so forth. We've asked for 64 in this case. Some summary information about the time taken. Useful thing, one, some people might be interested, it gives you memory high watermark. So that's the maximum amount of memory that's been used by the program. A load of information here now comes about the timetable. So what this craypat Lite instrumentation is doing is to basically interrogate the execution at regular intervals and form a statistical sample of where the program is as a function of those samples. So you don't actually get any absolute time in seconds out of this process, but what you get is a percentage in this picture. So this is telling us that out of 100% of the samples, 82% have occurred in user code, which is the code of the program that we have got, we have supplied, and it's telling us that 82% appears to be in this function compute forces multi-set, which sounds plausible if this is an n-body problem. It's also telling us 15% of the time has gone into various MPI activities in this case, and a small percentage of the time is in math library functions. So the first thing is this is telling you is that the vast majority of the time is going into that compute forces. So if you were to be worried about the performance of this program, the first place to look would be there. It presents effectively the same information in a number of different ways. This is by function and by, actually you couldn't try and identify exactly what line in the program is causing or what is using up given portion of the time and so on. There are some, I remember I mentioned yesterday that memory bandwidths might be important for an n-body, probably not, I would suspect, but that's some statistics on memory bandwidths, and so on and so on and so on. So that's a lightweight way to get some simple information about the performance of the program. If you want to do a slightly more detailed job, there is a slightly more heavyweight or non-light version which operates in a slightly different way, and the recipe is given here. So instead of perf tools light, you get rid of that and load perf tools. Remember, if you make a change, you need to recompile, and you actually need to produce from the basic executable an instrumented executable with a different name using this pat build utility, and then that is the executable you need to run. Okay, so you can, if you're interested, you can have a go with that. So this is just a slightly more complicated way to do a similar kind of thing, and you'll get a similar kind of output. And there are various ways of marshalling the output with this pat report utility to get at what you need. So that's the same kind of thing. So what the full CRAPAT version allows you to do is to build an executable with complete instrumentation, basically, which will actually allow you to get some actual times from the profiling rather than just a sample. So the thinking behind this is that this business of statistically sampling is quite lightweight and doesn't the act of measurement does not give you a significant overhead in time in the thing you are trying to measure. If you actually try to insert instrumentation to measure the true time in seconds of everything, that now can be potentially much more heavyweight, and you need to target that to exactly what you want. So that's the sort of philosophy behind having these sort of different levels of instrumentation. And if you do that process, you can actually get some true times in real units rather than just a statistical measure out. So that's basically what this is trying to take you through. So if you're particularly concerned with performance of particular sections of your program, that may be of interest. But I think that's probably as much as I will yes, so somebody's noticed in the chat, if you don't load the CRAPAT, sorry, the Perf Tools Lite module, you won't get that instrumentation added. So order is important. Okay, so slightly that's took slightly longer than I had anticipated. It's now 11:15. I suggest we have a break until 11:45, and I'll come back and just cover the last couple of short topics at 11:45. Okay, welcome back, everyone. Hope you've had a chance to get a cup of tea or a cup of coffee and have a break. These last two sections are really quite short and shouldn't take too long, but are basically some orientation about where to get further information if you haven't found it already. And then, as I say, we will be here until lunchtime to help you if you want to try, for example, getting your own code going. The other point that should be noted is that these accounts will be available to you for about a month, so you'll have a chance to do something useful. If you want to try and get some code going or run some benchmarks, should be an opportunity to do so before the full service arrives sometime in the new year. Okay, so this is just a quick view of where to get help. So the first port of call for any problems should be the help desk, which in the new dispensation should be officially referred to as the service desk. The email address is there. Sometimes can be easier to resolve a problem by actually a synchronous form of communication, such as a telephone call or a screen sharing session. So if that would be useful, email the service desk to arrange a time. The user documentation is at this site here. So if I go to this link here, we should find the user documentation. There are various sections. The main section is this one, ARCHER2 user and best practice guide. So there's stuff on stuff we've covered, like connecting and software environment, application development environment. If you're interested in stuff like containers, a bit more on Python, debugging and profiling, and performance. So all that stuff is there. There should also be details of libraries appearing, and various other stuff. So this is something of a work in progress, so it's worth keeping an eye on that to see if the latest advice is changing. As you're here, I assume you've all found out about ARCHER2 training. It's worth keeping an eye to see on what's coming up in the near future. So if we look at the upcoming training page, we'll see there's actually another run of this course. Perhaps you'll even get somebody who can type to deliver that. There's something on performance optimization on AMD. That's a new one, so that might be interesting in the future, but it's worth keeping an eye on that page. We run quite a lot of standard courses if you're interested in things like message passing with MPI and OpenMP and all that kind of stuff. There should be opportunities there. So hopefully most of you as ARCHER1 users will have a route to obtaining access through your consortia or standard projects or whatever. If you don't happen to be in that category, the simplest and easiest way to get access is via this thing called the driving test, which should be available in the near future. So if that's a fairly low overhead way to get access if you just want to try something out. Other than that, there are more standard Research Council proposal routes if you're in the business of writing research applications. And there are more details on that if you follow this link to the ARCHER2 access page. One last thing that may be useful for developers specifically is the so-called embedded science, computational science and engineering support, ECSE, which again is a reasonably low overhead route to get actual funding to perform development for software on related to ARCHER2. So that's quite a good way if you want to get some experience writing a grant proposal or something. That's quite a good way, and those calls are basically rolling. I think there's one every 3 months. So check out the main ARCHER2 website for that. The other thing we would like to ask is that there is a standard form of words for acknowledgements, which appears here if you're making an acknowledgement. Okay, so I think that's about that. Please let us know if any questions. If not, we'll just shoot on to this last section here. There's no way this is going to take 30 minutes because all I'm going to say here is that, so hopefully this course has given you enough information to get off the ground. If you have any questions, we'll be around and we'll be happy to answer. So other than that, if you wish to keep going with one of the earlier examples or have a go with your own code to try and get it off the ground, we'll help you as best we can. If you feel you don't have a specific thing to do, there's a small example using GROMACS as being provided as a canned example there, if you're interested in that. So I think that's probably about all I have to say. So unless there are questions, thank you for listening, and thank you for attending. As I say, we'll be around until lunchtime if you want to pop any questions into the chat.
So one question that we have got is asking whether it would be okay to use the TA009 budget to try out some of the codes that people are currently running on other systems.
Yep, I don't see why not. Please have a go. There probably is a budget of time there, so for tests, okay. Not production work, probably not. Yes. And if the time runs out, we can probably also always top up with a bit more.
I think the budget for this is 1,000 CUs. So as long as
yeah, so as long as nobody hits the big time, we should be okay. Yeah, please do go ahead and try things. That's the idea, please. Yeah. Please. Okay, so I'll say thanks for coming and goodbye now, and we'll watch the chat and answer your questions as they come in. Okay, Lamps question in the chat. Okay, Lamps, we can probably help you out with that. The easiest way to do it would probably be to share a screen, actually, if you're prepared to do that.
Yeah. I've not tried compiling with OMP, but it definitely compiles easily with MPI. I've got some instructions for building with MPI.
Is there a particular reason for wanting the OpenMP version? It's usually not as effective as the MPI one. Yeah, my advice would probably be to just use the MPI version. Is usually very effective.
Yeah, from memory, the OpenMP, adding OpenMP to lamps doesn't massively improve performance.
So unless there's a real, we could, Julian, you don't want to have a go now, do you, Julian?
I mean, I'm happy to. The best thing to do if you really want OpenMP is to send in a query to help desk and get it assigned to me, like specifically ask for me to go on it, and then I'll have a which OMP version are you after as well? Because I'm aware that there's a user OMP package, but I don't know, I'd be reticent to think that that was ideal. Though I might be wrong.
Yeah, thank you. Okay. So back to on the lamps, if my advice would just be to stick to MPI. So the one live issue of interest for lamps might be whether it would be interesting to use the Cocos version. I don't know. The user OMP stuff, depending on what interactions you want, it was rarely much benefit, was usually my impression.
Yeah, looking at the lamps docs, it seems that OMP would improve by maybe 5 to 20%, depending on the jobs.
Yeah.
The Cocos package is an interesting one as well that I should play around with. I should also play around with it on Cirrus, to be honest. Because Cocos from memory has nice ways of integrating GPUs.
Yeah, but it's the abstraction for the OpenMP in this context. Maybe may depend exactly on what kind of simulation you're after. Okay, to pass the time, I'm going to have a go at that OpenMP one with lamps now. So see how you can watch me, see how I get on, but I'll shut up now. Okay, so the first piece of advice I think for CMake usually is to check you're on the latest version. So there's a version of CMake coming from there, which is 3.10, and there's also a version, a later version coming from the module system. Which is a bit more recent, so that may be one thing to consider. And yes, as Julian has pointed out in the chat, there's probably some the C++ compiler needs to be announced to CMake.